Here in example 3, we're going to find real and complex zeros. So they're asking us what are the real and complex zeros of the polynomial function shown in the graph, and then we have the polynomial function listed here. So we want to figure out what those what those real and complex zeros are. Before I get even into the function and trying to factor this, I can use the graph to my benefit. And what I notice is that one of my zeros is going to be 2. All right, my graph crosses through 2, so I have a 0 of 2. And what that's going to allow me to do, let's make a little note of that. So let's write that down here. So we have a 0 of 2. What I can do is I can use synthetic division, and I can divide that 2 into my function itself. So I'm going to use 1, 1, -3, and -6. So remember that those numbers are being pulled right from your function. So use synthetic division. I'm going to drop that 1 down here. 1 times 2 would be 2. Add those up. 2 times 3 would be 6. Add those up. So we'd have 3. 3 times 2 is a positive 6. And we should have a remainder of 0. If you don't get a remainder of 0 here, something went wrong, because we already know that 2 is a 0 based on the graph. So that means it should go into your function. Okay, really the x minus 2 phrase, or x minus 2 expression, should be a factor of this function. So this piece here, let's change colors. This piece here can be rewritten as 1x squared plus 3x plus 3. Okay. So we know that my function f of x is equal to x minus 2, which is the first 0 that we found. So that was the one that we found in red, this x minus 2. So that's going to go here. And then we have this x squared plus 3x plus 3. Now, unfortunately, that is not factorable. So I do need to find the zeros, but I can't factor it, so I can't find the zeros that way. So I'm going to have to use the quadratic formula. All right, what happens here is, since it's a quadratic, right, to the squared to the second power, I can use the quadratic formula and will always give me the zeros, whether they are real or complex. So the quadratic formula, we would say x is equal to negative b plus or minus b squared minus 4ac over 2a. And in this case, we're looking at x squared plus 3x plus 3. So a is equal to 1, b is equal to 3, and c is equal to 3. So let's substitute those in. So we have negative 3 plus or minus 3 squared minus 4 times 1 times 3. And all of that will be over 2 times 3. So I'm going to simplify this. All right, start doing whatever you can to get this answer. 3 squared would be 9. 4 times 1 times 3 is going to be 12. And then 2 times 3 would be 6. So x is equal to negative 3 plus or minus square root of negative 3 over 6. Now, I can't take the square root of 3, so let's fix that in there. I can't take the square root of 3, but I can take that I. Remember that, sorry, not the I, the negative out as an I. I'm getting ahead of myself. So I can rewrite this as negative 3 plus or minus I radical 3 over 6. Oh, we made a mistake here. So I'm going to point this mistake out. This here, so that you can erase that, that is incorrect. That a value should have been a 1. Right, so let's erase that. So we got to fix this denominator here. Sorry about that. So this should have been, in fact, a 1. So we would get 2 in our denominator. And then we would wind up with x is equal to negative 3 plus or minus I radical 3 over 2. So these would be, we had one of our zeros was here, this negative 2, x minus 2. And then these are the other two. So let's write those out. So we could say the zeros are, and then we would have 2, and then negative 3, my 3's are terrible, negative 3 plus I radical 3 over 2, and negative 3 minus I radical 3 over 2. All right, and this would be your solution. So we have one real and two complex. We could see that from the graph, because it crosses that x-axis once, so we should have that one real solution. If you wrote your final answer with the two complex zeros combined with that plus or minus, it's not the worst thing in the world, but for now you only have 3 solutions, so you might as well write them out as each individual piece. There's also better ways to write each of these ones. You might see it written as negative 3 over 2 plus radical 3 over 2I, and negative 3 minus, negative 3 over 2 minus radical 3 over 2I. So it could be that, those three. It'll be determined like that's in your kind of standard form, your A plus BI form. So, if your teacher does require that or does ask you to do that, make sure you're writing it in the proper form. Okay, for this video, I'm just going to kind of leave it, I boxed it in already. I'm going to leave it that way. Now, running through your process one quick time. First step is always going to be use the 0 that you can find on your graph, whatever number that happens to be. In this case, it was 2. Use that 2. Use synthetic division by dividing that 2 into your coefficients of your function, whatever's left. In this case, it was 1, 1, negative 3, negative 6. You should always get a remainder of 0 in these problems. If you don't, then that 2 was not actually a 0, so something's wrong. And then you may be able to factor at this step down here on the bottom left. You might be able to factor here. We couldn't, so we had to use the quadratic formula. And remember that the quadratic formula will always work for a quadratic. So even if you don't like factoring, if you don't feel like you're very good at it, just go to the quadratic formula and it will give you the answers.